Announcement. Edit. Oh, come on. All right. Okay, folks, I had to send a correction because I lost the stream, and my stream was stopped for some reason. I don't know what happened. So I had to start another one. And today we're going to be talking about the integer exponents, which is lecture number 10. So I'm assuming you guys have checked the lecture before the class. And so the story here is about the integer exponents, which is the powers when you have the exponent of the power, or the power to be any kind of whole number. It could be positive or negative. For example, you can have 3 with the power of 4. Or it could be, I don't know, 2 with the power of negative 3. Okay? Or it could be 4 with the power of 0. Okay? So when you have something like this, then we have some names for it. So the whole thing we will call a power, right? So the whole thing is a power. This thing here, which is a superscript of the expression, we would call exponent. So this is something that could be any integer. It could be a positive integer, it could be negative integer, it could also be 0. And this we would call a base. base of the power. So you have the names for a couple of things that you have here. We will very often abuse the language here. So we're going to also very often call this number power, even though the whole thing is a power and the superscript is only an exponent of the power. So again, you have something like this, when this could be any integer. And so we said that before many times, that integer is something you need to remember, that name that is a label for something that is a whole number. It could be positive or a negative whole number or a zero. Okay? So what's the idea of this? Well, I'm sure you have seen this before. The idea is, if you write something like this, the meaning is that you're going to have to write 3 4 times, and you're going to multiply that 3 times. Right? And if you want to have a multiplication that would be 4 times multiplication, then you do this. So you basically need to write 3 4 times and multiply 4 times, but I have this one so that I can have 4 multiplications. That's just irrelevant, right? I don't have to have it. I have it just so that I can say I have 4 multiplications. Okay? Now, we also could have a negative number. And the idea when you have a negative power, so if 3 is with the power of -4, would be simply that negative means reciprocal. So you put up this into reciprocal format, and now you have the same power you had before. The only difference is now it's reciprocal. So this minus means reciprocal. So when you're turning a power that has a negative exponent, so this is a negative exponent, you're just simply going to turn the whole power upside down, and you're going to erase the negative. This is usually what we use for some very small numbers, and I'll show you that in the end. How is that going to happen? Okay. We also have possibility to have a 0. So you can have a 0 for the exponent. Now, when we have something like that, we're just going to declare this to be, so now you have to write 0 times, right? And you have to multiply that 0 times. So you can say, I don't have anything here. Well, you do have that 1. So we're going to call this to be 1. Anytime we have a power that has the exponent 0, we're going to call that 1. Okay, so this is just another very fancy way of writing 1. You want to write 1, you can write 5 to the power of 0. That's 1. Okay, we do make one exception, though. So you're going to have to remember, because that's an important exception. All right? This is undefined. So when you have a 0 as a base, so again, this is a base, and this is exponent. When you have a 0 as a base and exponent is 0, we are actually going to call this undefined. Now, the important thing about that is that we have a reason why we do that. And the reason is in calculus. So if you want to know exactly why we call this undefined and not, let's say, a 0 or 1, I have to say to you, you're going to have to study calculus for that, and you will see the reason in calculus that we don't really want to make a call here. So this is going to be undefined. But in every other case, when you have exponent 0 and you have a base, something that is not 0, you will always call this 1. Right? That's a convention. This is a convention because you're not multiplying anything here. So you're going to have a convention here too. This you will call 1, but when you have a 0 with the power of 0, you will call this undefined. And you got to remember that because that's going to come up sometimes in your problems. So you're going to have to remember this convention. Okay? Now, when you have this stuff like that, we do have certain properties you're going to use. So I do have a certain properties for you, and we're going to write them in the order that is going to be important to us. So the property number one is when you multiply two powers, that have the same base. Notice here, I have base A, and on the top there are two different things, like 2 and 3, or 1 and -5, or anything like that. The call is that this is equal to, again, the same base, and on top you do sum of two powers, or should I say exponents. Okay? By the same token, when you're dividing two powers like that, they have the same base, you're going to write that base again, and you're going to subtract in this order the one on the top, exponent, minus the one on the bottom, exponent. Okay, let me show you why that is the case. So, for example, like we have 3 with the power of 4, multiply with the 3 with the power of 2. Okay, you can see the base is the same. So that's my A in this property A. Okay, the first one, I'm having the exponent 4. In the second power, I have exponent 2. So this was my m and n. So I have 4 and 2. Okay, what we have here is 3 times 3 times 3 times 3. That's the first power. The second power is 3 times 3, the second power. And now you have to multiply them. So what do you have? You have 4 and 2, and that would be 3 with the power of 6. 1, 2, 3, 4, 5, 6. Okay, so that makes perfect sense. So instead of writing all of that, you can just immediately use the property number one. 3 with the power of 6. 6, 4 plus 2. Okay? The same thing works in this second property. The second property, you have something like this. 5 with the power of 7 divided with the 5 with the power of 3. What could that possibly be? Okay? This property says, since you have a base 5 here and you have a base 5 here, all you have to do is to write that base one more time. And now you're going to subtract 7 minus 3. That's the property. It says this minus this, m minus n. So that will be 4. Okay? Now, if you want to see the reason for that, the reason for that is you have 5 times 5 times 5 times 5 times 5 times 5 times 5 on the top, 7. 1, 2, 3, 4, 5, 6, 7. And on the bottom, you have 3 of them. 5 times 5 times 5. So you can cancel, 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 cancel. Common factors. Common factors, you can cancel them. And now you have 1, 2, 3, 4 left. So you're canceling 3 on the top and 3 on the bottom. Basically, you're subtracting 3 here. So these are all gone, and it's going to be 7 minus 3, which is 4 left. So you can see that makes perfect sense. The rule makes perfect sense. Okay. Now these are not the only two. We have actually a few more rules. The third rule is applicable on a power that is made into another power. So you have a power of a power. what we do here is we just write the base and we multiply the exponents. So that's the property. Okay? Now let me give you the reason why this property holds this way. So you have the, let's say, 3 with the power of 2, and then you have another power of, I don't know, 4. So I'm using very simple numbers. Okay, what do we have here? First of all, this power means that you have to write this 4 times. So you're going to have to write 3 with the power of 2, times 3 with the power of 2, times 3 with the power of 2, times 3 with the power of 2. That's 1, 2, 3, 4 times. And you have to multiply that. Okay? What's the first one? The first one is 3 times 3. What's the second one? 3 times 3. What's the third one? 3 times 3. What's the fourth one? 3 times 3. So what are you doing? You have 4 groups of 2. 4 groups of 2. How many? 4 times 2. 8 of them. 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Power of a power is resolved by multiplying the exponents. And you got to remember that. So that's this property. Okay? We have more. The property number 4 is this one. So that is actually a convention I already mentioned. So I already use this as a convention. So I said moments ago that when you have a 3 with the power of negative 4, you're going to do 1 upside down, 3 with the power of 4, and you're done. Okay, so you could say, all right, but this is just a convention. So why would that be written as a property? As a matter of fact, this is a property because this is going to hold no matter what the integer here is. So, for example, you could have 4 here. Now, how would you be writing this as a fraction? If you want to write this as a fraction, according to property, you're going to be writing here 3 with the power of what? Well, these two numbers are opposite. I didn't say this n is positive. So I'm not saying the n is positive there. It could be negative. So if the n is negative, you have negative of negative, which is positive, which is what you have here, positive 4. But if n is negative, then you have a negative. So this is what the property says. So that's a new thing. It's not a convention. It follows. Okay? Now you can actually show that this is the case, because how can you show that this is the case? Well, let's go. 3 with the power of negative 4, meaning what? 1 over 3 with the power of 4, because we know that this is just an upside down 3 with the power of 4. And now this is reciprocal of 3 with the power of 4, and this is reciprocal of that. And reciprocal of reciprocal is the original number. You take reciprocal of 2, you get 1/2. You take reciprocal of 1/2, you get 2. So if you do reciprocal twice, you get back what you had. So that makes perfect sense. Okay? Now I have to say that every one of those properties here, every one, 1, 2, 3, 4 of them, all of them applied when the exponent is integer. So, I mean, this does not have to be a positive number. This does not have to be a positive number. This does not have to be a positive nor a negative number. It could be 0. So any integer in place of m and n, this is going to work out. All of those properties hold. So m and n could be any integer. The only limitation, of course, we have down the denominator cannot be 0. In this particular property, you cannot have denominator being 0. Because you can't divide with 0. That rule is not going to change. Okay, now we have two more properties. Number 5 and number 6. Okay, I promise this is all. This is all there is to it. This property says like this. If you have a product of two numbers and you're making a power of that product, you're going to be doing the power of the first one and power of the second one, and you're just going to multiply that. The next property says the same thing for quotient. So we have A over B, and you are making a power of that. You can write it as a power on the top, power on the bottom. Okay? Now let me tell you why this makes perfect sense. So you have, let's say, A times B, and with the power of 3. Now the meaning of this, the idea of this is you have AB, 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 and you have to multiply that. But that's a cube, right? Cube, that's how it's called. So you write the base 3 times. This is the base, because this is a cube of this number, and this number is a product of AB. So you have AB, AB, AB. Now we know that we have a shuffle, that we can commute and associate this, reassociate and commute. So we can put EAs forward. How many we have? 3 of them. We can put the B's after that. And what do you have now? A cubed, B cubed. And that's exactly what the property says. If you want to make a cube of a product of two numbers, all you have to do is to make a cube of the first one and cube of the second one, and then you make a product. So which means that you can reverse this is product first, power second. You can reverse this. Power first, product second. So you can reverse the order, but only this way. And the same thing works for the quotient. So let me give you this idea. So you have A over B with the power of square. So what do? We have A over B times A over B. You have A divided with B here. It doesn't look like an A. Let me check it. Make it nicer. All right. So you have A over B. That's the guy. A over B. And you multiply. That's a square. So what do when we do fraction? We multiply the top, which is A times A, and we multiply the bottom, which is B times B. So you have a square on the top and square on the bottom. And I can see the rule. Square here. Now it's on the numerator and denominator. So you have a square of fraction. It's a square of numerator divided by square of denominator, which means you can distribute the square onto numerator and denominator. Just like you can distribute the power onto factors. So the property number 5 and number 6 are very similar. Only one talks about multiplication, another one about division. Okay? These are all properties you will need. You won't need anything else in terms of work with the powers that have integer exponents. Okay, so I'll give you a couple of examples how to use those properties. But before I do that, I want to show you a typical mistake that people do. Typical mistake. So do not ever do that. Okay? Now, if I ask somebody, if I ask some of you about this, I bet somebody would tell me you have the a squared plus b squared, right? That is nonsense. This is not true. First of all, you don't have any one of those rules that could justify that. None of those rules tells that you can do something like that. Okay, so that is a mistake. Because you're looking at something that looks similar to this, but here you have multiplication and here you have an addition. And that's a big difference. Right? So I can take some numbers, you can see there how that works. For example, 1 for an A and 2 for a B. Right? So let's put a plus here and let's put a square. So this is 3, and when you square 3, you get 9. Okay? Look what we have on the other side. We have here 1 squared, and here we have a 2 squared. So when you square 1, you get 1. When you square 2, you get 4. And this is 5. And 9 is not equal 5. It shows you immediately that this is not something you could do. You should not be doing that. Okay? And that's a typical mistake people like my students, and you, my students, right, would be doing. They're going to do something like that. You got to remember not ever do anything like that, because it doesn't have a justification. 1, 2, 3, 4, 5, 6. None of this rule talks about this. You don't have it there. So you just basically invented that yourself, and it doesn't work. Okay? So this is one of those things you have to be careful with. Okay? Many of your homework problems are going to ask you to write power or an expression with positive exponent or non-negative exponent. So the author of your homeworks doesn't like to have negative exponents. So you have to be able to do that. Okay? I'll give you one example. You can have something like that. So it says, write this with non-negative exponents. Okay, so this is what you have to do. Negative exponent is here. So you have 1 over a with the power cube. Now it's positive times b squared. And now it's easy to multiply that, because when you multiply a fraction with your number, the number goes on top, but that's it. Some people like to write like this, and then you multiply the top, you multiply the bottom. That's not needed, but it's the same idea. Okay, so now this is without negative exponent. This one is with a negative exponent. You have it here. So you will see that in your homework there will be questions that will ask you, write this with positive or non-negative exponents. You shouldn't have negative exponents. It's not because it's impossible to have them. It's just sometimes we don't like to have them. Okay? Anything you do with the powers fits well with anything you know about the fractions. So whenever you say, okay, well, I was doing that with fractions this way, and now with these powers I have to use those rules. Not really. All you have to remember is that if you don't have anything better, you could use rules. But if you know something else, and that was working in the past, you can use it now. Okay? So let me give you an example. So you have this. This is one of the examples in the lecture. You might want to check it out. You can use it. You can use the power rules. What power rules you have? Well, you do have this rule. So you have one power on the top, another power on the bottom. This is the story. One power on the top, another power on the bottom. So this is what you do. So you can write this as a with the power of -4. Why? because the property says you are subtracting 3 minus 7, which is a with the power of negative 4. Okay? Now, of course, a with the power of negative 4 is what? 1 over a with the power of 4. So that's one way of doing it. But you can also use the things that you know about the cancellation of a common factor. Cancellation of a common factor. That is done when you have a fraction. Factor on the top and factor on the bottom, if they are the same, they can be canceled. You're actually dividing up and down with the same number, and that number is that factor. You're reducing. Okay, so that's what you have here. Why? Here you go. A. 3 on the top, 7 on the bottom. 1, 2, 3, and what is left are these 4. You got the same thing you have here. So cancellation, and you get the same result. Rule, power rule, number 2, you have the same result. What do you know? You should know both. But if this is more convenient to you, go for it. So you use the cancellation of a common factor, no problem. Okay? I have to warn you now, again, about a mistake that I get from people like you're doing all the time. You can say, oh, I don't like those rules, they're complicated, I don't want to remember that, so I'm going to use something that I think works. Okay, that could be a problem. Something like that. I don't even have to have a fact. I don't even have to have a fact. Power here. So I have a plus 2 divided by 2. I did. People do all the time stuff like that. Oh, let's cancel this, and we have an a here. Nonsense. Again, you should never do anything like that. This doesn't work. It's not correct. What's the problem here? Well, this one you can consider as a factor because you can write this if you like. 1 times 2, that's 2. So you can say, I have a factor here. Okay. You can have a factor. But this one is not a factor, no matter what you do, because it says a plus 2, not a times 2. So this is not a factor. So you have a factor and something that is not a factor. And even though it's common, you don't have a common factor. You have common something, but it's not a factor, which means you can't cancel it. You cannot cancel something that is not a common factor. So you got to remember that. And if you don't believe me, take some number here. 1 in place of a. 1 plus 2 divided by 2. What was that? That's 3 halves. And this is 1 here. 3 halves and 1 are not the same thing. So you have 3 halves here, and you get 1 over there. So again, when you're using cancellation, make sure you know what a cancellation is about. Cancellation is actually a division or a reduction. Now, you want to make this simpler? What are you going to do? Canceling common factor. 8 is 2 times 4. 6 is 2 times 3. 2 factor. It's multiply. 2 factor. It's multiply. Common factor. Cancel. 4/3. Okay? What you're basically doing, you're dividing this guy by 2. You get 4. And you're dividing this guy by 2. You get 3. And we talk about fractions in the very beginning of our class. We said that you can multiply up and down with the same number, and you can divide up and down with the same number. And that's exactly what I'm doing here. I'm dividing up and down with 2. So that's what the cancellation is about. Okay? So again, if you are using cancellation and you don't want to use the power rules, that's perfectly okay as long as you know what the cancellation is about. So if you start canceling something that are not factors, that basically means you don't know what a cancellation is. Then maybe you should not be using it until you learn it, of course. Right? So let me give you a couple more examples. You can see it in the lecture, some of this stuff I didn't write down. So I have the example number in lecture, example number 10. It says negative 6 y with the power of -1. It says write this without negative exponents or with non-negative exponents. What are you going to do here? Well, we have one problem here. This is a power. This is a power. Make no mistake about it. This is not a power. It's just a number -6. Right? So this is the power. And it has a negative exponent, -1. So what are you going to write? You're going to write upside down y with the power of 1. Now, what's a y with the power of 1? That means you need to write y once, and that's it. So it's just a y. You could keep this one, but it's really usually not written. So if you don't write, it's going to be simply the base. Okay. Now, sometimes I have people like you. If I put it in the test, stuff like that, people like you will, not necessarily every one of you, some of you know this stuff, but some of you that don't know this stuff, they're going to write this like 1/6y. Okay. That's a nonsense. Okay. Again, this -6 is not a power, so it's not going to go upside down. You cannot do that. Okay? So you got to remember this. You cannot turn -6 into 1/6. For one thing, it becomes positive, and before it was negative. And now it's a different number, right? 6 and 1 divided with 6 are totally different things. So don't flip this stuff, because this stuff is -6. It's not a power. So this negative doesn't mean reciprocal. It just means negative, opposite. Okay? So the things that get flipped is this guy, because it's a power, but this is not a power. So be careful. If you start using this property number 4, you make sure you use that in a way the property is to be used. Only the way it was written. Okay? I have another one like that. Let me see. -2a. So this is I think example number 13. Okay. So what are we going to do here? Well, we could do something inside first, or we could do this guy first, which is the power of product. Now, where do we have that? We have that here, power of a product. So what product we're talking about? We're talking about 3 things. This one here, this one here, and this one here. That's all multiplied. She can do first this times this, like the first part and the second part, and then you can do this times this. But one thing to remember that comes out to this property number 5 is that this could be distributed onto factors. 1, 2, 3 factors. So you could write -2 with the power of 4, a with the power of 4. That's the second one. The first one. The second one. And then the third one. And make sure you include parentheses, because if you don't include parentheses, it will read negative 34, and that's not an intention. So that's a mistake. So now I work it out. This one is negative 2 times negative 2 times negative 2 times negative 2. That's 16. Okay. This one here is a to the power of 4. This one here, our next property, number 3. Or should I say previous property, right? It's a power of power. So you write b with the power of negative 3 times 4, which is negative 12. Now you could stop here, but if you want to write this with the non-negative exponent, you're going to have 16 a with the power of 4 times 1 over b with the power of 12. Or you can now write it as a single fraction, 16 a with the power of 4, b with the power of 12. And you don't have any more negative exponents. Everything is positive or non-negative. Okay? So you got to remember this. So I did use the property number 5 on 3 things. The property number 5 is 2 things, but you can go 2 and then 2, right? Like the same thing when you multiply 3 numbers, you multiply the first 2 and then the third one. That way you can use the property the same. You distribute them on this and this. Now if this one is made out of 2 things, then you're going to continue to distribute on the first one and the second one. Okay? So this is something that you might be required. Now, if you're going to go any further with mathematics, you're not going to stop at 111. You will have to learn this properly. Okay. So let me give you another one. Worth remembering. Number 15. In the lecture. So I'm referring to the stuff that is in the lecture. Lecture is written. It's on the blackboard, so you can write it down yourself. So you have 2x to the power squared, and I have y to the power negative 3, and downstairs I have x with negative 1 and y with negative 1. Okay. There's a couple of ways to do this. All right. The easiest way to remember is you have to identify the factors. Now, if you can identify the factors, this is going to be the easiest way to do. This is one factor. This is another factor. This is the third factor on the top. On the bottom, you have 2. Number 1, number 2. Factors only. Okay? If something is not a factor, then what I'm doing now, you will not be able to do. So what do we have here? Well, 2 and x squared. I'm going to keep these 2. Everything else is a power with a negative exponent. The power with a negative exponent can be flipped. What does that mean? Well, I can put this one downstairs. I'm using the property number 4. This one upstairs is going to get 1 here, but you don't have to write 1. This one upstairs is also going to get 1, and you don't have to write that 1. So you don't really need to write 1 and 1. But this is what happens. So again, this one stays where it is. This one stays where it is. It has a positive exponent. This one moves downstairs and changes the sign of an exponent. This one moves upstairs and changes the sign of an exponent. Now it's 1 here. This one upstairs and changes the sign. It's going to 1. It's going to be 1 again. Now what? Well, you have cube here. X, X, X. X, you have Y here, and you have Y, Y, Y. You can cancel 1 Y, up and down. Common factor. They're all factors here. 2x, x, x, y. All of them factors. So y is a factor upstairs. And downstairs, y is a factor. Y, y, y. So if you cancel y on the top and one of those 3 y's here, you are left with 2 of them. Done. Okay? And you got to remember, this is always a possibility to happen, stuff like that. And it's always worth remembering. So I'm going to give you one kind of like complicated example. Right? First of all, anything you're going to be flipping will have to be a factor. So this is a factor, this is a factor, this is a factor. This is a factor, this is a factor, and this is a factor. And again, you gotta remember, the factors are numbers that produce multiplication. So there are something you're multiplying, not something that you want to be flipping. You want to flip, and you're not multiplying that. That is not a factor, so you can't flip it. You gotta remember that. So now, what do we have? Let's see. This one goes down there, changes the sign of the exponent. -2, now it's +2. This one stays where it is. This one goes down there. Power, -5, now it's 5, changes the sign. This one stays where it is. Okay? No mistake here. This one and this one are 2 different things. This is guy that came from the top, and this is the guy that was in the bottom. Now this one here goes upstairs. Changes the sign. Now it's -3, now it's 3. This one goes upstairs. Changes the sign. Here is -2, goes upstairs, becomes power of a square. And now you can work this out. What do we have? We have b with the power of 5. Downstairs we have a with the power of 4. And what else we have? 2 c's here and 5 c's here. So we're going to kill 2 here and 2 here. Now if you kill 2 here, you will end up with 3. C with the power of 3. So this will be C, 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 and this is C, C. So you cancel C and C, up and down. Common factor. Okay? Makes perfect sense. So this is what you can do. Okay? Now let me show you something you cannot do. And I see that all the time. So it's something people do, but it's not according to any of those properties there. So when you're using something that you cannot find here, then you make sure you can justify that. If you cannot justify that, then it's probably not true. Okay, here's an example. So somebody's going to look at that, is going to say, oh, okay, I have here power with a negative exponent, so you can just flip it. Maybe I'm not going to put square, it's just like that. Okay? Well, sorry, but that doesn't work. That is not true. First of all, you have no justification here. You don't have a justification because this is not a factor. It's a term. You're adding it. You're not multiplying. So it's not a factor. So you can't just flip it. Because the only way you can flip it if it's a factor. Okay? You can check this out very easily. Take something for A, something for B, something for C. So A is 1, B is 1, and C is 1. So you have 1 plus reciprocal, this is reciprocal of 1, which is 1. So you have 1 plus 1, which is 2, divided with 1. That's 2. Downstairs you have 1, 1, 1, so this is 1/2. And 2 is not equal to 1/2. So this is incorrect. So again, flipping something that is not a factor will be a mistake. So make sure you understand this. Okay, let me give you another example. So this is example I'm picking up again from the lecture, which is example number 18. In this example, I have 3x to the power of -2, y to the power of -3, and then we have 15 x to the power of -4 and y to the power of -5. Okay? There are two ways to do this. You can start flipping the stuff if you're convinced they're factors, and then reduce, and I'm going to do both ways. Or you can use the properties. Which property? Well, this one here. So let me show you how that works. First, by flipping. Well, okay, I have this one and this one, which is simple reduction. Divide with 3 upstairs, divide with 5 downstairs. Okay, so now I have upstairs 1, which I'm not going to write, and I might. So 1 on the in the numerator and 5 on the denominator. So that just reduce this piece. Now the next thing is this x with the power of -2. That one goes down there, and now becomes a power of square. So it goes down there and changes the sign. This one, power of a cube, goes down there and becomes a power of a cube. This is a negative cube, of course, and this is a positive cube, so it changes the sign. This one goes upstairs, changes the sign of an exponent. Okay? Maybe this was the reduction, so maybe I'll write it here on the side so don't think it's a power number. Okay, now this one upstairs and becomes a power of 5. And now you can do cancellation. So what do we have? I already canceled this. I am going to have x, 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 2 x's get canceled, they're all factors. So I have 2 that are going to stay. So I have 4 here, I have 2 here, 2 and 2 get canceled, I have 2 left. I have 5 y's here, I have 3 y's here, all factors. Cancel 3 and 3, and I have y with the power of cube left. And downstairs I have cancel this, and I have only 5 left. Done. That's one way of doing it. So I was flipping and then canceling. Because I like to do cancellation, I know how to do reduction well, so I don't need to use power rules. What if I use power rules? Okay. If I use power rules, first of all, to be able to use the power rules, I need to use this, right? So I will have something else here. I will split this into 3 over 15 times x to the power of -2, x to the power of -4 times y to the power of -3 divided with y to the power of -1. 5, -5, excuse me. So this times this times this. Why is that? Is that possible? Of course it is, because when I multiply this, I'm going to have this time this time this, which is here, and this time this, which is here. So I could do that. Now I have here 1/5. I'm just reducing it, dividing up and down with 3. Here, by the power rule, I have -2 minus -4. Why is that? Power rule. You write a base, and you subtract up minus down exponents, right? -2 minus -4. That's right here. And I do the same thing here. Why? -3 minus -5 again. I'm using the same rule here, power rule. All right? So now I have this 1/5, and I have x. This is +4 minus 2 is squared. And this is +5 minus 3 is also squared. And I have the same thing I had moments ago. So then I have x squared, y squared divided with 5. So this is by using power rules. So what I'm saying here is you can use a power rule or you can do the cancellation. Either is fine, and they're not in conflict with each other. They are in harmony with each other. So you can use either. Okay? Let me go to the last example I have out of this stuff. I have to do lots of cleaning here. So this is the example that is in the lecture number 20. All right. It says 2 x to the -1, and then I have y with -2, and all of that is with the power of squared, and that ought to be divided with the 4 x with the power -4, y with the power -5. And it says simplify this, make this without any parentheses, and we don't want to have negative exponents. Okay, so what do we do here? Well, first of all, we're going to work on the top. I need to have this, this, and this considered as factors, and there's a square. And according to property number 5, the square, the power, could go separately on each factor. So I'm going to have 2 with the power of 2. I'm going to have x -1 with the power of 2. And I'm going to have y -2 with the power of 2. And that's going to be divided with 4 x with the power of -4, y with the power of -5. And now it's easy. First of all, this is 4 and this is 4. And it's a common factor, so you can cancel. What else we have here? Well, this is a power of power. That's the property number 3 here. Power of power. So you're going to have x with the power of, you multiply these two. The same thing here. Y with the power of -2 times 2. And downstairs you have x with the power of -4. Y with the power of -5. Now you can finish this by doing the rules, or you can do the cancellation. So I'm going to do the cancellation. So which means I'm going to flip the first. I'm going to flip first all of the factors. This one goes down there. This one goes down there. This one goes upstairs. This one goes upstairs. And I can do that because they're all factors. And now I can do the cancellation. You can see I have 4 x's here, 2 down there. I'm going to have 2 squared, x times x. Here I have the y, 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 y. Here I have y, 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 y. Cancel 4 of them. And the one y is left. Done. Okay? So at this point, I don't want to use the rules. I could have used the rule number 2, but I mean, I would have an x -2 minus -4. It would be x -2 plus 4. It would be x with the power of squared. And I could do the same thing here. -4 minus -5, and there will be -4 plus 5. There will be 1. I just did flip, and now I just simply cancel that. These are common factors. These are common factors, and I could cancel it. Okay? All right. Now, where do we use the powers? We'll use them everywhere. For one thing, for example, we'll need it very soon. But one place you use power that you have seen in your calculation in your life, when you have your calculator and your calculator is giving you something that's very hard to understand what it was. Something like this. Sometimes you get something like that in your calculator. What the heck is this? It's actually what we call a scientific or exponential notation. Right? So some calculators are going to write that. Some of them are going to write EE. And on you go. Well, what is here? What we have here is 2.135 times 10 with the power of negative 22. So which means you are going to be, this is the 10 with the power of 22 upside down. So you're dividing this number 22 times with 10. That is a very, very small number. It's something like this. I need to go. Let's see. I need to get 22. Maybe I make my life a little bit easier. I'm going to put here 12, so I don't need to write 22. So now I have 2, 1, 3, 5. Let me see. I get this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, here. This is what it is. So when you divide this number 10 times, or excuse me, 12 times with 10, that's what you're going to get. The first time you divide it, you're going to move the floating point here. The second time you divide, you're going to move another floating point, another floating point, another floating point, another floating point. So basically, you move that from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times, because you divide it with 12. So this is a very small number. Okay? And instead of writing stuff like that, we prefer to write stuff like that. Okay? And your calculator is going to write like this, because your calculator doesn't know how to write this in 2 lines. This is a 2 line, 1 line, a second line. And your calculator doesn't do that, so it writes everything in a single line. But that's the idea. So what's a scientific notation? This is a scientific notation. Okay? You have 2 parts of the scientific notation. This part here, that must be a number that must have significant value here, which means it cannot be 0. It has to be 1 minimum. But it can't have 2 digits here. So you can't have 10. You cannot have 13. You can only have 1 digit. And that digit must be significant, which means it has to be 1, 2, 3, 4, 5, 6, 7, 8, or 9. Again, it cannot have 2 digits, and it cannot be less than 1. Here, you have 2, so that's good. What follows here is whatever it should be. And then you have this x, which means multiplication. It's not an x. It's a multiplication sign, that old-fashioned multiplication sign. Then you have a power of 10. In exponent, you're going to have an integer. Now, in case it's a negative number, that means you're going to be dividing this number with 10 this many times. In other words, we're talking about something very small. Something very small. Okay? I'll give you another example. E. coli bacteria. E. coli bacteria is a very small thing. Okay? When you have lots of them on your food, it will make you sick, because it has an ability to spoil the food and deposit various poisons on the food. E. coli bacteria is a live thing. It's not like virus. It's just really something that lives on its own, but it releases toxins. So if you get it in your body, it's going to poison you. Right? It's not a virus. It just makes poisons that poison your stomach. All right? But it's a very small thing. Very small thing. It weighs something like 4 times 10 with the power of negative 16 pounds. So if you look at a typical E. coli bacteria, that's going to be the weight of one. Okay? It's a very small thing. You can see it if you don't use a microscope. You only have you can see it if you use a microscope. It's much bigger than a virus. So this virus we have around now is much smaller than E. coli bacteria. E. coli bacteria is bigger than a virus. And it's a living thing. Virus is not generally considered not to be a living thing. Right? But this is a living thing. It lives independently of you. It doesn't need you to live. It's living on a food. Okay, so what do we have here? We have here, so this is a 4. We have here to divide 4 with 10, 16 times. So we're going to have 0.0000000000000. So now I need to go 16 times. So they have floating point here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There you go. So I move this floating point from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 times. I have 1 0 too many. Okay? Now you see what that means. We could write this. E. coli bacteria weighs this many pounds. That's just really difficult thing to write. You can't. It's not something you want to write. Okay, so we write it this way. To give you a little easier way to write it, that's again scientific notation when you have something very small. So this is the weight of your average E. coli bacteria. Again, one is not going to poison you, but if you have lots of them on your food, it will. It doesn't hurt you in your organ or anything like that. It doesn't eat you, but it will give you some toxins that releases some toxin, and you're going to get sick out of that. Okay. Another thing you can see, sometimes you see the stuff that is very big. For example, what can I imagine that is really, really, really big? Sun or star that you can see during the day. That's the permanently exploding hydronuclear device, thermonuclear device. Sun is a thermonuclear bomb, but it's contained with the gravity, so all we get is radiation only. We don't get all that pieces that would come out of that if they could explode. So we just get the radiation. Well, the gravity keeps it together. But that's so great because we get sun that is important for life on the planet. If we don't have a sun, we would be close to absolute zero temperature, and there would be nothing alive around here. Okay, so what is the mass of sun? How heavy the sun is? This many tons. Sun has 1.989 times 10 with a power of 27 tons. Now, if you want to write that without, so this is a scientific notation. Notice again, number, you have a significant digit before the floating point, and you have some other digits over there. And then you have 10 with a power of 27. So this is multiplying with 10, 27 times. Now, if you're going to do that, you're going to move this floating point 27 times that way. So this is the mass. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. All right, so we check it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7. Perfect. Okay? I don't even have a name for this number. This is bigger than trillion. Right? So this would be a million. Then I would have a million millions. Million, million, millions. Million, 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 millions. And then I have the final 1,989. I was lost track. Million of million of million of millions. Tons. That's a huge thing. And it's really nothing, because the center of our galaxy is 3 million times heavier than a sun in the center of our galaxy. And our galaxy is kind of a small galaxy. So there's some stuff that is really big. So from our perspective, of course, sun is a huge thing. And so if you want to write this number and you want to refer to that you're writing a paper about sun, and you're going to have to write stuff like that, that is this, how heavy it is, what is the mass of sun, and this is much more convenient. Okay, much simpler number to write. So that's why we use a scientific notation. Again, so when the power is with a positive exponent here, it will mean that you have some really huge number. If the power here is with negative exponent, then you would be dividing this with 1027 times. That is not the case here. Then you will have something very small. So we have very, very big things in the universe. And then we also have very, 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 very small things in a microscopic world. And the E. coli is much bigger than, for example, virus. Coronavirus is much smaller than E. coli. But there are things that are much smaller than coronavirus. Atoms, subatomic particles, they're much smaller. And on we go. We don't even know what is further. So there are some very, very, very small things. And if you want to express those, you're going to have to use scientific notation with the negative powers like that. And there are some very, very big things. If you use a scientific notation, you're going to have to use some power of 10 that is with the positive exponent. So that's what we use. Okay? Now, this is my story for today. I am going to finish it. Now, you have a homework. The homework is called Integer Exponents homework, in which you're going to practice all the stuff we have, in particular those 6 rules, which you need to learn. And because that homework is going to be on your next test, number 3, sometime down the road. All right? So next time we meet, we're going to go over the lecture number 11. All right? So I'm going to leave this stream on YouTube for a while, so you can go and watch it again when you need it. All right? Okay, I'll see you next time around.